Hello guys, welcome back to Techdose, and in this video we will see the count unique characters of all substrings of a given string problem, which is from Leetcode number 828. So this is a substring count or a window count type problem. Before looking at the problem statement, I would like to announce about our live interview training program, which occurs for 3 months, and it is a live interactive program happening on all the weekends, Saturday, Sunday, which contains data structures and algorithms. And you will also get live doubt clearance with the curated assignments, and you will also get your interview guidance. If you want to know more about the course, then you can connect us on WhatsApp. Let us now look at the problem statement. In this problem, it is said that let's define a function count unique characters of S that returns the number of unique characters on S. For example, calling count unique characters of S where the string is Leetcode, then L, T, C, O, D are the unique characters since they appear only once in string S. Therefore, the count of unique characters is equals to 5. Now you will be given a string S. Return the sum of the count of unique characters of the string T, where T is actually a substring of S. The test cases are generated such that the answer fits in 32-bit integer, so you will not see any overflow in the count. Notice that some substrings can be repeated, so in this case you have to count the repeated ones too. So you will have to count the repeated substrings too. Let us now look at some examples in order to get some better understanding. Now in this case, on the left hand side, let's assume that you are given a string S, and let's say the string is ABC, and the goal is to count all the unique characters in all the substrings of S. So one simple way can be just enumerate all the substrings of S and count the unique characters in all possible substrings and just add them up. So if you get the string S as ABC, then all the substrings of S will be A, B, C, AB, BC and ABC. Now if you look at all the substrings, then the count of unique characters in all the substring, like the count of unique character in A is only 1. In B it is 1, in C it is 1, in AB it is 2, in BC it is 2, and in ABC it is 3. So the total count of all the unique characters over all possible substrings of S will be equals to the addition of all these numbers, and this will be equals to 10. Now if we look at another example where there are repeated characters, you will see that all possible substrings will be A, B, A, AB, BA and ABA. Okay. Now if you count the unique characters for all the substring, like for A it will be 1, for B it will be 1, for A it is 1, for AB it is 2, for BA it is 2. Now if you see for ABA, this A, the first A and the last A are repeating, and so they will not be counted, and we will only count B. So the count of unique characters in this substring is 1. So the total count will be equals to the sum of all these counts, and it will be equals to 8. So our goal is to find out the total unique characters in all possible substrings of a given string. So I hope you understood the problem statement, and the simplest approach can be to just generate all possible substrings of a given string and count all the unique characters and just add them up to get the result. But that will take a lot of time, since you already know that for a n length string you will have order of n square number of substring, and minimum time will be n square. Now the intuition for solving this problem is counting of all the unique characters in all substrings of S is equals to the sum of total contribution of each character as unique character in all the substring of S. So if you look at our previous example, then how many unique characters we had? We had 3 unique characters A, B, C. Now each of the characters contribution can be added in order to get the total unique character contribution. Okay, so let's see that with an example. Let's say that your string is AB. Now the substrings where A is uniquely present, we have to see the substrings where A is uniquely present are this A and this AB, right? So AB for the first A. For the second A you will have this BA, this BAB, right? BA. So you have BA, you have BAB. Then a single A can also be present, so this is also given, and AB is also present, so this is also given, right? So I have written those in 2 different columns for the first A. This is for the first A. the contribution from first A, and this is the contribution from the second A. I have not written ABA because in ABA, A will be repeating 2 times, so it cannot be included. And similar is the case for ABAB, because here A is repeating twice. So you can't take all those substrings where A is repeating, right? So since I am counting the contribution made by A, I will take all those substrings where A is uniquely present. And then I will add, like I will count all these substrings. So this is 2 plus 4, which is equals to 6. 6 number of substrings. So the total contribution of character A is 6. Now we have to count this for all possible characters. And in the question you are given from A to Z, so we can have a total of 26 characters at max. Here I have counted for A. In this case we have only A comma B as the unique character. So let's count for B. For B, if you look at it, for the first B, if you look at this first B, its contribution will be AB, B, BA and also ABA. So AB, B, BA and ABA. All these 4 from the first B. From the first B, because I cannot repeat B twice, okay? Now again, if you look at the second B, this is from the second B. And the second B is to the right hand side and it contains B and AB. You cannot include a BAB, right? And you also cannot include ABAB, definitely, because B will be repeating. So the substrings will be B and AB. Now if you add all these contribution, you will have 4 plus 2, which is again equals to 6. Now you do not have any other unique character except for A and B. So you are done processing all the characters in your string. And so the count of all unique characters in all substring of S will be equals to the contribution from A and the contribution from B, which will be equals to 12. Okay, I hope you are understanding the intuition, how it is getting solved. Now the next question can be how to count the contribution of each unique character. So we should focus on learning how to count the contribution of each unique character, and so it is just a repetitive process for all the characters and you just need to add them up. So let's take a bigger example. Let's take that the string is ABC ABDA. Now given a character or given a string, a single character can either be occurring once or it can be a repeating character, right? So let's first solve for a non-repeating character. In this entire string you will see that D is not repeating, it is a unique character. So if you are talking about the contribution made from D, then we have to include all those substrings which are containing D. And the cases which can arise from all these substring can be a substring ending at D, a substring which starts at D, or a substring which contains D somewhere in the middle, like somewhere in between, right? So let us see what are all those substrings which are ending at this D. And you will see that it is ABC, ABD, BCA, BD. So this one, ABC, ABD, then you have BC, ABD, you have CA, BD, you have ABD, BD and D. All these are the substrings which are ending at this D. Now if you try to find out all those substrings which are starting at D, then it will only be DA. Now I am not including D again because it will again be repetitive, because I have already counted D here, so I cannot write it here again, right? Otherwise we will be counting it twice, which I don't want. So DA is the only substring in this case which is starting at D. Now if you consider the third case, like the substrings which contains D somewhere in between, so you will see that ABC, ABDA is a substring, which is actually the entire string. You will have BCA, BDA, CA, BDA, ABDA and BDA, right? So now you just need to add all these substrings, and this is 6, this is 1 and this is 5, and if you add them up it will be equals to 12. So this is the total contribution made from D. Now if you closely look at all these calculations, you will come to know that the contribution of D is not all about enumerating all the substrings which are containing D uniquely, but it is also about if you can take the left window, like this is the left window, right, which is containing D uniquely, and if you can take the right window, so this is the right window which contains D uniquely. What is the size of it? The left window size is 0 to 5, so this is 6. The right window size is 5 to 6, which is 2. And if you just multiply them, you will get all possible combinations which are containing D uniquely within the substrings, right? You will get all possible substrings. So this is nothing but doing cross product. Now, if we look at this technique as well, then just for calculating the contribution of D, which is a non-repeating character, you will see that I will have to take the left window of D, which is this one. Then I will have to take the right window of D, this one. You find out the total number of characters in the left window, which is equals to 6. 5 minus 0 plus 1 is 6. And this is 6 minus 5 plus 1 is 2. And the total number of such combinations will be equals to 12. So if you look at it by enumeration, then the left window, all possible substrings in the left window will definitely end at D. So what are all the substrings ending at D? ABC, ABD and so on till this D. This I have already written on the previous page, right? And all those substrings which are starting at D, you will see that this is D and DA. Now in this case I have written it repeatedly. You will see that this is nothing but a join operation or a cross product. Cross product or a join operation. And in this operation, this D, this particular column and this first column, like this last column and the first column are the same element. So if you have seen the join operation on a table using a column, we do not repeat that column. So in this case as well, when we take the cross product or a join operation, this D, when it is joined with this D, it will not be repeated but only be written once, because this is the common key. Now in this case, if I write it again, then you will see that ABC, ABD will be multiplied with this D, right? And if you join them, then this D and this D will merge together and it will be the same string. And if you write all of them combining with this D, then it will be nothing but the same substring, right? So this is where I have written it. But if you combine it with the second one, with DA, then D will be common and then A will be appended to the end, right? So you will see that all these combinations are written on this portion. And then you will just add them up to get the total result. Now this can be shortened up. You do not actually need to enumerate all these substrings. So what we can do is we can just multiply the count of it. Like here the count was 6 and here the count was 2. So all possible combinations will be equals to 6 into 2, which will be equals to 12. This is what you need to write. And so we can write it as the left window size multiplied by the right window size, which will be equals to 12, right? So finding of the all possible substring having D as the unique character is nothing but the cross product of all the substrings or the window on the left side, which uniquely contains D, multiplied by all the substrings or window on the right side, which is uniquely containing D. Now D was unique, so we had taken the entire string and divided it into two parts at this point D, right? Now how to calculate for the repeating characters? So let's take an example for A. Now for a repeating character, you will have to take different slices and you will have to consider them as a separate string where A is occurring uniquely, right? So I am calculating for A. You see that A is present at 0, at 3 and at 6. So what will be the slices of the substring where A will only be present one time? So the first slice will be this one, ABC. Now in this slice, A is occurring only once. This is the largest first slice where A is occurring only once, right? And in this case, if you see the left window, it will contain only A and the right window will contain ABC. So if you can just multiply them 1 into 3, it will be equals to 3. And I have also written the enumeration of it. The left window will contain A, the right window will contain A, AB and ABC. Right? And if you combine them, you will get A, AB and ABC. Now what about the second A? If you look at the second A, then it should not contain either the left hand side A or the right hand side A. So the slice for this second A will be this big. Okay. Now in this particular slice from index 1 to 5, the left window will range from 1 to 3. So its size is 3. And the right window will range from 3 to 5. So its size is also 3. One character has to be in common, right? In order to apply the join operation. Now the total number of such combinations where A is included only once, including the second A, it is equals to 3 into 3, which will be equals to 9. So you have to write the cross product enumeration of these two windows, right? And similarly for the third window, you will see that you should not include any A on the left side and any A on the right side. On the right side you do not have anything, and on the left side you have a A at 3. So the left window size will be ranging from 4 to 6. It is of 3 length, and the right window size will only be of size 1. So you multiply them together and it will be equals to 3. So there were 3 A's and the contributions were 3, 9 and 3. So you will add all these contributions and it will be equals to 15. We had already calculated for D, which was equals to 12. Now if you try to calculate for B, then you will see that you have two B's here, right? The first B has a left window size of 2 and the right window size of 3, which is from 1 to 3, because you cannot include the fourth index, otherwise B will be repeating. And so this is 3, so 3 into 2 is 6. So this will be 6, and for the second window, you will see that this B has a window size of 3, and on the right hand side its size is also 3. So 3 into 3 is 9. So the total contribution from both the B's will be 6 plus 9, which will be 15. And similarly, you can calculate for C. You have only one C, right? So if you have only one C, the left hand side window will be of size 3 from 0 to 2, and the right hand side window will be of size 2 to 6, which will be equals to 5. So 5 into 3 will be 15, and we already know that for D it is 12. So the total contribution from all the unique characters of this substring is equals to 15 plus 15 plus 15 plus 12, which is 57. This is what we want to find, that is count of unique characters in all substrings of S, right? So this was our goal. Now the solution technique will be to keep track of all the window sizes, like the left hand side window and the right hand side window sizes. In order to do that, given a string S, you can maintain a list of list or a map of list, where the maps key will be the unique characters which you are solving for. In this case, it can also be a list of list format where the indexes are given. Now in this case, I have only A, B, C, D as the unique characters, but in the problem statement you can have from A to Z, which is from 0 to 25. Total 26 characters you can have it. Now in this particular example, I will write down all the indices where A is present. So A is present at index 0, 3 and 6. So 0, 3, 6 is given. Now I will append, I will like prepend all the list with -1, so that I can always have the left hand side window, right? I want to have the left hand side window. So for this A, the left hand side window, on the left hand side you do not have any element. So if you subtract this index 0 with -1, then you will get definitely a value of window size 1, right? So that is why this -1 has been prepended or appended in the beginning. Now this 7 is appended at the end for the similar reason. Let's say that for this A, I do not have anything on the right hand side. So I will subtract from 7. 7 minus 6 will be 1. So the right hand side window of this A will be of size 1. And similarly for this D, you do not have any other D on the right hand side. So its window size will be 7 minus 5, which is 2, right? So that is why the string size is appended at the end and -1 is appended in the beginning. And all the occurring indices are there in between. So we have to iterate over all these elements, right? So if you want to find out the contribution of A, then you have to go to this point, like the contribution of A, let's say CA is equals to 0. When you are at 0, you find the left hand side window, So the left hand side window will be 0 minus -1, it will be size 1. Right hand side window will be 3 minus 0, which will be equals to 3. You multiply them in order to find the cross product, and this gives you a contribution of 3. So this 0 is updated to 0 plus 3, which is 3. When your pointer goes to the next A, then the left hand side window will be 3 minus 0, which is 3, and the right hand side window will be 6 minus 3, which will be equals to 3. And so the total contribution will be equals to 9. So 9 will be added to this and it will become 12. When you go to the next one, which is 6, left hand side window will be 6 minus 3, 3, and the right hand side window will be 7 minus 6, which is 1. So the contribution is 3, you add 3 and it will be equals to 15. So this is how you can iterate over all the indices, all the yellow colored indices, the actual indices, and you can calculate the contribution for each character, and you can keep adding them for all the characters, and finally you can return it as an answer. So I hope you were able to understand the intuition and how to solve this problem. The time complexity is definitely the length of string, and we do not involve any other time complexity in this. So this is the simple code implementation which I have written. Here you will get your string S, and I have taken a list named as hash map. It's just the name hash map. Like, I have not created any hash map. It is just a dynamic list. Now in the question it was mentioned that you can have from capital A to capital Z, so you will have total of 26 characters numbered from 0 to 25. So that is why I have taken a size of 26. Now I will iterate over all the list, and I will prepend all the list with -1. Okay, all the 26 list with -1, and then I will go to the entire string and I will append the indices wherever they were occurring, right? 1 2 0 1 2 4 7 and so on, right? I will prepend all the indices where the particular characters are occurring, and finally all the list will be appended at the end by the string size with a value n, so that I always have a left hand side window and a right hand side window. Okay, I hope you know the explanation, like I had already explained that. Now I will take a counter equals to 0, and I will iterate over all these list and will keep on adding the contribution by each of the character. So this is iterating over all the character, and this is counting contribution for each character. So the count maintains the contribution for all the characters in all unique substrings, and finally we return the count as answer. And this entire solution is order of string length, which is, let's say, order of n, where n is the string length. I hope you were able to understand the logic and all the explanation behind this problem. If you want to know more about the Techdose course, then you can WhatsApp us and you will get all the details regarding the course. If you like this video, then please hit the like button and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.